So this is the 8th session on friction. In this also I will take up a numerical problem on kinetic friction. This is a question which was asked in IIT JEE 2004 PYQ. Okay, IIT JEE 2004 it was asked. This problem was asked. So this first I will solve this, write down the question, and then I'll solve it. Okay. See, I'll just write down the question. Okay, so I'm just going to write down the question. Question is this. Consider the diagram shown below. In which all the details are given. All the details are given. Okay. Problem is this. We have an inclined plane, fixed rough inclined plane, which makes an angle of 45 degree with the horizontal. Here we have two blocks. We have two blocks here, small blocks B and block A. G is to be taken to be 10 meter per second square. Both the blocks are released from rest simultaneously. Okay. A and B are simultaneously released from rest. Simultaneously released from rest. Okay. And one more thing we are given. Coefficient of kinetic friction. Coefficient of kinetic friction for blocks A and B. Are 0.2 and 0.3 respectively. Point 2 and 0.3 respectively. Okay. And initially block A is root 2 meter behind block A, block B. This is given. Block A is root 2 meter behind B. Is root 2 meter behind block B. Okay, fine. Now the blocks are released from rest. Question is this. Question is where will the two blocks come to on the same line? When they are released from rest simultaneously, then after some time A and B come on the same line. After some time A and B come on the same line. Okay. This was the initial situation of two blocks and they are released simultaneously from rest. A and B come on the same line on this inclined plane. So question is where will the two blocks come to same line on the inclined plane? Where will the two blocks come to the same line? Okay, to come to the same line if they are released simultaneously from rest. Okay, fine, all right. Now I have this. Okay, all the details are given. This are a bit now. So see, both the blocks are released simultaneously from rest. Okay. And friction coefficient here is 0.2, here is 0.3. They move simultaneously, begin to move simultaneously from rest, and they come on the same line somewhere here. We are asked to find what distance will they move till they come to the same line. Suppose B moves a distance L before they come on the same line. Then A in the same time moves a distance of how much? L plus root 2 meter. Okay. Suppose the blocks take t time to come on the same line. Okay. Now first what I do, I draw the free body of this block B. I draw in the side view. Okay. I am drawing the side view. Side view I am drawing. Side view block B will appear something like this. Mass of both the blocks have the same mass. Both the blocks have same mass given. mg. NB is the normal force on block B due to the rough incline. And when it slides down, friction FB acts on the block B up the incline. Now block B is slipping over the incline, so FB becomes mu times NB. Mu K times mu KB into NB. Okay. Now mu KB is how much? 0.3. NB is how much? Mg cos 45 degree. This is theta. 45 degree is given. NB becomes Mg cos 45 degree in 1 by root 2. Now block B starts from rest and it begins to move down, so it accelerates downward. So we first what we do, I find down the acceleration of block B with respect to ground down the incline. So what do I write? Mass times AB. AB is what? Acceleration of block B with respect to ground. What do I write? It will be equal to mg sine 45 degree minus FB. So MAB becomes mg sine 45 degree 1 by root 2 minus FB is 0.3 into mg by how much? Root 2. Now m goes away. So AB becomes 0.7 g by root 2. G minus 0.3 g, 0.7 g. G is 10. This becomes 7 by how much? Root 2 meter per second square, which is a constant quantity. I hope it is clear. G minus 0.3 g becomes 0.7 g. 0.7 g by root 2. 0.7 g becomes 7. 0.7 into 10, 7. 7 by root 2 is constant. It is down the incline. Okay, fine. I love this one. Now, suppose the block B takes t time to cover a distance L. Its acceleration AB is constant. It starts from rest. So, from the formula D equal to ut plus half at square applied to block B, what do we get? L equal to 0 into t plus 0 because initial speed of block B is 0. Start from rest. Half AB into t square. So L becomes half. And what is AB? 7 by root 2 into t square. This is the distance moved by block B till A and B come on the same line. Okay. Now what I do, I rub this one. Now I repeat the same thing for block A. What I do, I draw the FBD of block A. I draw it in the side view. I am drawing the side view of the situation. This is again 45 degree angle. This is block A. I draw the free body of block A with respect to ground. Mass of both the blocks are given to be equal. Say m each. Na is the normal force of block A due to incline. And block A slides down the incline, so friction acts on the block A up the incline. Now Fa is how much? Mu A into what? Mu A into what? Na. Mu A into Na. Okay. Now mu A is how much? 0.2. Na is how much? Na is mg cos 45 degree. Cos 45 degree is 1 by root 2. This is the Fa. Now this block also starts from rest and begins to move down the incline. So it accelerates down the incline. Say with some acceleration A. I apply Newton's second law to block A down the incline with respect to ground. So mass times acceleration of block A is m times AA. That is same as mg by root 2 minus Fa 0.2 mg by root 2. So now m goes away. A becomes g minus 0.2g, 0.8g. 0.8g by root 2. G is 10. 0.8 into 10 is simply 8. 8 by root 2 meter per second square, which is also a constant quantity. Okay. Now in the same time t, block A undergoes a displacement of L plus root 2. As I applied this formula for block B, so I apply the similar formula for block A also. Now I rub this. Okay. So this I rub it now. Now block A covers a distance of L plus root 2 in time t, starting from 0 initial speed and constant acceleration of 8 by root 2 meter per second square downward. So what do I write for block A? L plus root 2 is simply 0 into t plus half into A into t square. Okay. L plus root 2 is simply 1 by 2 into 8 by root 2 into t square. So this is the first equation and this is the second equation. From this equation we have to determine the value of L. So we need to eliminate t square. Okay. If you eliminate t square, problem then is fully solved. Alright. Now this I rub it. So now I eliminate t square from these two equations. So from this equation 1 we see that t square by 2 root 2 is how much? L by 7. This is t square by 2 root 2. See, t square by 2 root 2 is equal to L by 7. Now t square 2 root 2 is replaced by L by 7 here. Equal to 8 into t square by 2 root 2, which is simply L by 7. So root 2 is 8L by 7 minus L. So root 2 is equal to L by 7. L is equal to 7 root 2 meter. Okay. So this is the distance moved by block A down the incline till A and B finally come on the same line. This is therefore the required answer. Okay. So L is equal to 7 root 2 meter. That is the required answer. And distance moved by block B, A, this is the distance moved by block B before A and B come on the same line. And distance moved by block A will be L plus root 2, 8 root 2 meter. Okay. So this is the distance covered by block B before A and B come on the same line. And distance moved by block A is L plus root 2, so 8 root 2 meter before A and B come on the same line. This I have solved it fully. Okay. So in case you have any doubt, you go through it properly. If you have any doubt, you put your doubt in the comment box. I'll fully explain it. Alright. So in coming more videos, I'll take up more problems on kinetic friction. All types of problems I'll take up. Okay. I close it here. Finally.